Okay, so welcome to another Spring Showcase. Today marks Showcase 32 for Spring, and we'll be hearing from Anglian Water on how they have worked with partners to build CReDo, a climate change adaptation digital twin that will help the sector to better understand if, how, and when assets could fail due to extreme heat in the UK. For those of you who might not already know, Spring is the Innovation Centre of Excellence for the UK and Ireland water sector. So we're here to create centralised intelligence around what already exists in the water innovation space. Our goal is therefore to enable collaboration, remove duplication, and accelerate innovation in the water sector. Spring also puts out calls to innovation against the 7 themes in the WIS 2050, which will be linked in the chat in the moment, through our accelerator service. We're currently in the midst of running Spring Accelerator 4, which is based all around emerging contaminants. You can find out more about that on our website and apply with your own innovation ideas on our platform. Again, links for all of these will be put into the chat shortly. But today's service offering is all about knowledge sharing, and I just wanted to touch a little bit on why we do these deep dive sessions before we jump into one today. So globally, the water sector is under significant scrutiny at the moment, as we know, and we really need to accelerate problem solving. And knowledge sharing is one of the ways in which we can do that. So over the last 6 months, we've partnered with our economic regulator for England and Wales to build out a view of what best practice knowledge sharing should look like. We brought together senior leaders and innovation managers to design a vision for knowledge sharing. So what is it we're trying to achieve? And ultimately, we want to unlock faster adoption by creating a world-class knowledge sharing culture. We then built out 6 best practice principles. Number 1 is learn from what already exists before committing to innovation projects. So we are building a centralised source for what already exists so that you can come and check in with us before making any investments and beginning any sort of long haul projects. Number 2 is target innovation insights to the right audience to meet our objectives. So we want to make sure the right people are listening to the lessons. So for today, do we have our data strategists, engineers, asset managers here? And do we have the right decision makers involved in the lessons learned? Number 3 is insights are regularly shared through multiple channels from day 1 of the project. So historically, knowledge share is regularly happening at the end of a project, but we want to start moving towards a model where we share from day 1. Sector knowledge is open and centralised, so we want to make sure that we're all being open and honest when it comes to knowledge from innovation projects, and we want to make sure it's all in one place, i.e. Spring. So number 5 is insights from both innovation successes and failures are shared. As we know, the lessons learned from failures are just as important as the lessons of success. So hopefully we'll be hearing about some of those from our presenters today. And number 6 is people are empowered to receive and embed lessons from external sources. So Spring and the presenters on this call can all share knowledge, but we want to make sure that the receivers of the knowledge have the resources, the capacity required to actually make those changes and that they feel empowered to do so. In terms of what will be shared, I'd encourage you all to take a look at the Water Innovation Strategy 2050. Again, that was linked earlier. For anyone who hasn't seen that document, it outlines 7 main themes with challenges sitting under those themes that we're currently trying to tackle. We'll also be hosting an interactive webinar about these best practice principles on the 21st of November. That will be an open session hosted alongside Ofwat, and a link to that will be put in the chat in a second, so please do sign up if you'd like to come along to that one. Back to today, I'd just like to give a warm welcome to all the audience members who are joining us live. We are joined by 12 UK and Ireland water companies today, which is great to see, and lots of overseas colleagues too. So welcome to the call, everybody, and thank you for joining us. We will be linking a poll at the end of this showcase to find out how interesting you found today's information and how likely you are to go away and actually use it afterwards. So please do submit your answers at the end of this event when that comes through. It really helps us. And you'll also get the chance to ask the project team any questions at the end of the session today. So make sure to keep putting your queries in the chat throughout the presentation. So on to today's session. I'm just going to run through the agenda and introduce our speakers quickly before I hand over to Dave. So we'll start off with a bit of importance of knowledge sharing from Dave. So why do we actually knowledge share? Then we'll go into a little bit of what is CReDo and how the team are making extreme heat weather data available. and building and using models to assess risks. We'll then look at the actual asset risk tool and a deep dive into digital twinning. We'll then have a quick break and come back for lessons and next steps and questions and answers. So speakers wise, we'll be hearing from Dave Riley, Head of Carbon Neutrality at Anglian Water, Alana Gluck, Engagement Lead at Connected Places Catapult, and her colleague Stefan Fernandez Garcia, Data Strategist, Jethro Ackroyd, Principal Engineer at CMCL, and Tom Bergignon, who is Asset Systems Specialist at Anglian Water too. So without further ado, Dave, I will hand over to you.
Leah, that's great. Thank you. And good morning all from if you're in the UK, or maybe good afternoon or good evening if you're in other parts of the world. So first of all, thank you for joining this really important project. If we think about the challenge of dealing with climate change, responding to climate change, ensuring that we maintain water supply and recycle water back to the environment on behalf of our customers and the environment. This is a project which is really future looking. And I say future looking, but if we think about climate change, it is happening right now. So this is relevant for today. And the knowledge sharing piece is really relevant for today. So hopefully you've been able to see slide progress. Is that working, Leah, at the moment?
Yes, Dave, sorry, you just need to take control back.
Yeah.
Just press that button again.
Take control, right. So you can see I'm extremely useful at using technology. So hopefully you're on an exploring heat scenario for the water sector slide.
We are, yes.
Yeah, great. Okay. So why is this knowledge sharing so important? So I've been working in the water industry in terms of carbon and climate change for over 20 years now. So I've seen and been at the forefront in terms of actions we need to take, not only to reduce our impacts on the environment through reducing our emissions, but also how we look at our assets and ensure that our assets are being designed with a future climate impact in mind. And to get to that point, to have that knowledge sharing, such as what we have with Spring and through other organisations such as UCWEAR, I've seen the benefit of things like the carbon accounting workbook within the water sector of the UK to allow us to have a consistent approach. And that consistent approach and having an ambition where we're all heading in the same direction is really important in terms of this collaboration piece. And I've seen, as this project's grown and developed over time, the real importance of having a diverse group of individuals who all input their thoughts, all input their views and their skill sets from across the water sector and beyond to output something that we will be sharing today. So that collaboration piece, the clear communication, the opportunity to share this work that's been done by Anglian Water and colleagues within the sector, it is important because it's now an opportunity for you on this call to understand more about CReDo and understand more about how it's being developed and how you can start to utilize this within your own organizations and the roles that you take as well. Because as this is the intent and the objective of this, the more individuals who are part of this process, the more chance we've got of delivering actually success and making change and transforming change in terms of how we are designing assets with future heat in mind in terms of climate change. So the final point I make on this slide is that the outputs of this project were funded through the Ofwat Catalyst program, and looking at how our assets are impacted by extreme heat. So I think it's a big thumbs up to the regulator here and recognition of the importance of actually funding this type of work. So why is it important? Why do we need to look at extreme heat in terms of climate scenarios? Well, if I go back 5 or 10 years, I was looking at scenarios that were approaching, say, 35 degrees C across our region in the UK for a period of 10 days, and that might happen by 2040. How wrong was I proved? The scenarios that we were putting forward only 5 or 10 years ago are already way out of date. And in fact, in the summer of 2022, we saw temperatures exceed 40 degrees Celsius for the first time. And so that just blew away anything that I was appreciating and we were thinking about as a team at that point in time. And what the impact of that was that we we were having to deal with temperatures that were unprecedented. And as the picture here illustrates, we were having to bring in mobile AC units to keep our pumps cool. Somebody's taking control of the. Sorry about that. Somebody's taking control of the slides. Hopefully we're back on this slide again, which is extreme heat and climate scenario. So not only were we dealing with these unprecedented weathers, we were having to bring in things like mobile air conditioning units to keep our pumping assets cool. And it had an even bigger impact in terms of our wider asset base, where we were the volume of water we were pumping increased by about 35% from 1.1 billion litres of water every day up towards 1.5, 1.6 billion litres of water. So that change in temperature meant that from an operation perspective, we were dealing with those unprecedented levels and really thinking through how does heat now impact on our assets. And we want to move away from that response to how do we actually plan for those different heat events in the future? What impact will it have on our assets as a single asset across our whole system? And what's the impact in terms of the other infrastructure assets that we connect to? And that's really where the thoughts of CReDo start to come through and the benefits of CReDo come through. And if we think about heat in the future, that what we are modeling is that we're going to see increased frequency, increased duration, and an increased intensity. So how do we deal with that? So that 40 degrees C, even though that was an extreme temperature in 2022, that will become the norm in the future. And how do we deal with that when it does become the norm? So that lack of understanding around heat impacts on our assets, that the impacts on our system as a whole really is where this project started to materialize. So what is CReDo and what will you see? So what we are trying to do here is recognize that climate change and the impacts on our assets of things like flooding and heat is a really complex area, because it's not just about water assets, it's how it's connected into other infrastructure such as power, such as communication. So it's taking that complex problem and trying to simplify it into what the solution looks like. Now, somebody keeps taking control, so I do apologize and moving the slides around. So what CReDo is, it's a web-based tool. So it's free to use, which is always great. So there's no fee involved. You simply have to register for it, and you'll find out a little bit more from the presenters on how to do that. It's aimed at people involved in planning, involved in designing assets, involved in operating our assets, those who have an interest in how extreme heat will have an impact on how water company assets operate. And this is an evolution of a 3-year project. So CReDo's been around for about 3 years, and it's probably the first time that I have seen what we refer to as a connected digital twin actually delivering value and actually something that we can tangibly see where we are using data to drive different decisions in how we are designing and changing our infrastructure. The first part of CReDo started about flooding, so it was working alongside British Telecom and UK Power Networks, so looking at communication and power and thinking through if one of those assets was impacted by a flooding event, how would then that cascade through to the impacts on our assets within Anglian Water? So if UK Power Networks lost a substation from a flooding event, and therefore we lost power to one of our assets, and therefore that took it out of use, it's recognizing that the flooding impact isn't directly on Anglian Water, but it's on a part of infrastructure which is connected to Anglian Water. And therefore, again, we need to understand the different scenarios of those flooding events and the actions that we need to take in terms of planning for it and designing our assets differently and working with our partners differently. Now, this has evolved to now look at heat. So it's ringing up the dial in terms of CReDo being used not just as the flooding aspects, but also from an extreme heat aspect. And colleagues on this call will start to go through the process that we've employed to really understand how heat impacts asset failure. So it's really looking from a perspective and an asset risk tool. And it's looking at that piece around what I've already said in terms of if we can use CReDo effectively in the future, we'll have a better understanding about the connected and the cascade risk that occurs from a changing climate and from those increased risks that we see from the intensity of heat and how heat will impact on our asset and on our system. So my ask of this and our ask of this is that to understand what CReDo is, how it works, how it's been developed, but then how you can get involved in the future in terms of how you to use this tool to really think through how will we be changing how we are designing, constructing, maintaining and operating our assets in the future alongside other infrastructure owners, so that in 10 years' time, we know that CReDo has played a part in terms of making sure that our assets are more resilient to a changing climate. And if you've seen the news recently about warming sea temperatures, about the flooding that we've seen in Spain and other climatic events that are happening around the world, this is now our opportunity to make sure that we are ready for those climatic events because they are happening now. This is not something that we can simply talk about for the next 5 or 10 years. It's about using tools such as CReDo to really change the way that we are designing and operating our assets. So finally, I will hand over now to Alana, and hopefully Alana will have better use of the technology and that the slides won't be moving around for yourself, Alana. So I will stop sharing.
Thank you so much, Dave, and thank you, everyone. Just to reintroduce myself, my name's Alana Gluck, and I'm the engagement lead for CReDo, and I work at Connected Places Catapult. So just to reiterate what Dave said, CReDo starts with the problem that we don't have a clear understanding of the interdependencies across our infrastructure systems, so that when we are hit by extreme weather events, for example, the recent flooding in Spain, we don't know exactly what will happen to our assets, which ones of those assets will fail, and at what point we might lose power, communication, or running water, which really impacts communities. The Climate Change Committee has been saying for some time now that we have poor understanding of infrastructure and dependencies, and asset owners need to do something about it. The Joint Committee on National Security Strategy has also published a number of reports which show that we are not ready for the extreme storms that lie ahead, and this is going to cause major problems for us. And really what underpins all of this is data sharing across sectors. So the real crux of CReDo is that it's a climate change adaptation digital twin which brings together data across energy, water, and telecoms networks. And as Dave said, and obviously why we're here, we've been working with Anglian Water, BT, and Openreach and UK Power Networks, who are bringing their people and their data to the project. In CReDo's connected digital twin platform, we're able to bring together data about assets so we can see the connections between them and the networks. And when you can see those connections, you can see interdependencies across the systems. So to date, we've been focusing on the coordinated strategic resilience planning use case for CReDo, whereby CReDo can identify the most critical assets across the system that cause a cascade of failure. if you can identify the most critical asset, so here in the diagram, it's the yellow dot, which represents an energy substation, and it has the red indicator with the 3-pound sign next to it, indicating need for investment. And it's that most critical asset. And if that most critical asset fails, then it causes failure across all the other connected assets in the system. So the blue dots, which are the water assets, would also fail. So it's possible to see that in order to increase the resilience of the water network asset, the blue dots, it's important to invest in and protect that energy asset, the yellow dot, which is at the root of the failure. And in CReDo Catalyst, with the CReDo Asset Risk Tool, which we'll provide a bit more information on later in the presentation, we've been focusing on the blue dots in the diagram, understanding how and at what point would water assets fail under extreme heat conditions. So this asset risk tool is a key building block for the larger vision of CReDo. So I'll now give you a sense of where we are in the CReDo journey because as I've mentioned, developing the asset risk tool is a part of the larger picture. And this journey started in 2017 with the report Data for the Public Good, which was published by the National Infrastructure Commission and recommended that there needed to be a pilot project to show the benefits of cross-sector data sharing. And CReDo became this pilot project, launching in 2021 under the Center for Digital Built Britain. After proving the concept in its first year, CReDo has been taken forward by Connected Places Catapult since April 2022 and has been developing a CReDo prototype to scale up. And we've now been lucky enough to gain innovation funding from both Ofwat, which is what we'll be talking about today, as well as Ofgem to take CReDo forward to scale. So we're on a journey where we hope that ultimately infrastructure asset owners, regulators, and local authorities will be able to use CReDo as a tool to improve resilience across the whole of the infrastructure system. And the CReDo Asset Risk Tool is a key building block of CReDo. In developing CReDo Asset Risk Tool, one of the problems we've had to address is the lack of historical asset failure data and climate data. So I'm going to hand it over now to my colleague Stefan, who's going to explain a bit more about how we address the lack of data in this particular Ofwat funded project. Over to you, Stefan.
Stefan, your volume's not coming through.
Hear me now?
Yes, but you're very faint.
Fantastic. Thanks for that. Yeah, it was just saying thanks, Alana, and hi everyone again. I'm Stefan Fernandez Garcia. I'm a data strategist working at in the CReDo project here at Connected Places Catapult. As you've heard, this project main aim was to increase our understanding of the potential risks from heat events to the water and wastewater industries. And we started that journey thinking about climate data. So the first thing we needed to do was to define what a heat event is in a way that it's relevant to those risks that we want to understand. And to do this, we worked with experts at Anglian Water and we defined a heat event as the number of consecutive days where the maximum forecasted temperature is found to be within a specific range. Together, we identified 3 different temperature ranges, so 30 to 35 degrees, 35 to 40 degrees, and 40 to 45 degrees, and 4 different durations of events. This is 1, 3, 7, and 14 days. So if we consider all these potential combinations of values, we have 12 different events, and we have considered these in the context of 3 different warming scenarios, 1.5, 2, and 3 degrees. So these parameters are all based on the tacit knowledge from asset managers and engineers at Anglian Water, and essentially they represent the kinds of conditions that are likely to have an impact on the assets. That said, you can see we have covered a range that goes from relatively mild conditions that might not cause too many problems, as well as more extreme threatening heat waves. So now considering this definition of a heat event, We have then taken the most recent iteration of UK climate projections data from the Met Office, and we have obtained a first estimation of how likely it is that different regions in England and Wales will experience this kind of weather events. It is important to mention as well that climate science is a really complex field, and the Met Office models that have generated this data we have used may not always precisely replicate historical periods. And this is normal. It's what we call bias, which is essentially the difference between what these models in UKCP 18 predict and what we have actually seen in reality. But to make sure this first estimation of this likelihood of these weather events provides a better representation of reality, what we have used is what we call bias-corrected data that was kindly provided by Dr. Alan Kennedy and some collaborators as well. And bias-corrected data is essentially a way of reducing that difference between what the climate models say and what we then see in reality. So basically, using this type of data, what we achieve is basically we obtain a better and more representative results about that likelihood of experiencing those heat wave events, as I was mentioning. So to recap, we have these 12 combinations of temperatures and durations that we call a heat event. As shown on slides, some of these examples could include experiencing 30 to 35 degrees for a single day, or 35 to 40 degrees for 3 days in a row, or 40 to 45 degrees for a week, for example. So all these possible combinations of these values of temperatures and duration, as I was saying. And then for each of those events, as I said, what we have done is we've worked with DMV and Professor Simon Ted with these Met Office data corrected, and we've calculated the probability of experiencing such conditions. So for example, at the bottom of the slide, you can see I'm showing there is a region in England that has a 47.2% chance of experiencing a temperature exactly between 30 to 35 degrees that lasts a single day. And we have all these chances of occurrence for all these different events for England and Wales, as I was saying. Just to finish this recap, this is a quick screenshot of what that data looks like when visualized on the CReDo Asset Risk tool for one of these events. So each of those squares that you can see on that map would represent like an area where one of these events would be taking place and the probability that it takes place in that specific quadrant, if you like. Later in today's webinar, we'll be showing you how a user could access this data using a prototype tool. But before we do so, I would like to spend a bit of time talking about what we're calling asset modeling. By asset modeling, I mean, how do we use this climate data I was showing a minute ago in conjunction with other information to obtain a first assessment of the risk to different assets to these heat events. So this is about how we go about understanding how assets, like for example, a motor or a whole site, are vulnerable to heat and quantifying the corresponding risks associated to that. In CReDo, we use a formal methodology called expert elicitation to build our asset models. We've been developing these for a few years now with a few of our academic partners, Professor Jim Smith, Dr. Kevin Wilson, and Professor Chris Dent. And this approach can be really useful when you don't have much historical data to work with. And this can be either because of for example, a lack of digitization, but it can be also because of a lack of fault collection, for example, or because simply these events that you're trying to model haven't happened before. So for example, many of these heat wave events we just defined on previous slides haven't happened before in the UK, or have only taken place a very limited number of times. And so it can be difficult to use more like standard data-driven approaches like machine learning to assess some of these corresponding risks. So in that kind of situation, one possible alternative is to use expert elicitation, where you essentially work with subject matter experts, who in this case, for example, could be engineers that do asset installations, maintenance and repairs, as well as, for example, operational managers or even suppliers of these assets. Basically, a subject matter expert in expert elicitation is anyone that has a deep knowledge and experience about how these assets in question behave in a wide variety of real-life situations, and can therefore make reasonable inferences or guesses about what's likely or not likely to happen in these heat events or other kinds of situation. And so expert elicitation then is a method that we use to collect, formalize, and encode the tacit knowledge, the judgments, the opinions from these experts that are only found in their heads, into models that we can then use to assess the risk to different assets. So building models with expert elicitation is a two-stage journey. We start with what we call structural elicitations, and for this we run a first round of interviews with assets and operation experts. And the first objective of those is finding out about the type of assets and sites that are vulnerable to heat. And then for those, it's also about understanding what's the chain of events that would lead those assets and sites to develop faults and ultimately impacts, such as, for example, supply interruptions. This collection of information is what we call a model structure. And here on the right, you have a very simple conceptual example of how a structure could look like. It's essentially a diagram of that chain of events that starts with the extreme weather event, in this case, and ends with some sort of impact. And along the way, there are different kinds of events that could develop. Finally, structural elicitation is also about finding out about other variables that can play a role in making that chain of events more or less likely to happen. So if you think about inverters tripping, for example, the environment in which that inverter is installed and operating, for example, whether there is forced ventilation or not, etc., might be key in what is the likelihood that it trips in a 40-degree heat wave, for example. So you want to know about this kind of dependencies too for your modeling. And these dependencies are also really useful because in many occasions, they can also represent the types of interventions that you can do to reduce risks once you understand those risks. Once you have that information gathered in that structure, so that chain of events I was just mentioning a minute ago, you can then move on to the next stage in the process, which is what we call probability elicitation. And this is a second round of interviews where you would be asking the experts to make an inference, so basically an informed guess about how likely they believe each of those events in the chain is to take place at different conditions of temperature, etc. And at the end of that interview, what you end up with is probability data that, used together with a model structure, can be coded into a functioning mathematical model that takes the form of Bayesian network. So ultimately, expert elicitation is just a very advanced and targeted form of data collection on asset risks. So now, of course, in water and wastewater networks, there are many different types of sites, equipment. So how we have managed this complexity is something you might be wondering now. So because, of course, we cannot do an elicitation for every single possibility or every single slightly different type of machine. So what we have done is build models for the main type of vulnerable equipment we have identified, and then use those as building blocks for more complex sites or for other equipment that are similar. And I'll show you how this works in a minute. So an example of one of these building blocks are motors. And if we think about the model structure for a motor, it could be something like this. It would start with a heat event, and then there would be 3 different events or mechanisms of faults that could take place. So for example, the oil in a gearbox could thin to the point of causing damage or other problems. And it could be that a motor overheats, for example, reaches some sort of safety limit and it shuts down to avoid an unsafe situation. Or it could be that an inverter or a starter trips, for example. So all those events could lead to a situation where we say the motor can fail. And by this, we mean that it stops to work in this context. As said before, we also care about variables that could make those events more or less likely to happen. So in this case, for example, we could be considering things like the environment in which that motor or the inverter are installed and working, and how hard the motor is working. So motor is one of those main pieces of equipment for which we have done expert elicitation, but we have also done this for other 4 pieces of equipment or infrastructure. This is process control electronics, standby generators, microbial populations in aeration and final settlement, and what we call power supply infrastructure, which is essentially the key pieces of equipment that guarantee electricity supply to a site. And with those, what we have done in this project is reuse this information of these models to represent a variety of equipment operating on different sites. So now the question would be, how do we use these building blocks to, for example, describe how a specific water pumping station will behave in a heat event? Let's try and see an example about that. So in this slide, we have a model structure for a pumping station. One of the main potential vulnerabilities of this pumping station is actually the water pump ceasing to operate. And this can happen, as shown on screen, because of a problem with its motor, for example, and you could consider the impact that the ventilation itself could have or not in this motor. Another way the pump can fail is if its control electronics develop a problem, And again, you could consider that those electronics are in a ventilated space, etc. And we can see the corresponding nodes, so the gray boxes in the lower part of the structure. And the third, last way in which a site is vulnerable is if it was to lose its electricity supply. And this is the last part of the structure on the right. So now that we have this full, relatively complex structure, as I said, what you want to do is avoid having to elicit this for every single pumping station in your network. So what you do is reuse the information of those building blocks. So what we have done is we have taken the motor model information that we had, and we have inserted that motor model into some of the spaces in this pumping station site where we needed to represent the behavior of a motor, and so on with process control electronics, wherever we need that, standby generator or power supply infrastructure, etc. So reusing information in this way provides us with an efficient solution, basically, to be able to reasonably describe the behavior of these more complex sites without having to go and elicit similar information with experts over and over and over again every time we have a slightly different, like, for example, pumping station or type of motor, etc. So the last thing I want to talk about is that, okay, so now we have functioning models for different machines and for different sites. And the big point is that we can use them to understand risk. So I want to go back to this pumping station model I was showing earlier, a bit simplified now because I've taken the ventilation out just to make it a bit easier. And we have this model, and we can answer different questions at different levels of granularity now. So, for example, we could ask the model, what is the chance that the pump motor fails? And it will give us an estimation. Or we could ask about the chance of the electronics failing, and we'll also get a number about how likely that is. One interesting thing these models can do is that we can use the model to calculate joint events. So, for example, we could calculate what is the chance that the pump fails because of any of the things that can lead it to a fault. So, for example, and essentially this would be a combination of the motor and electronics faults in this case. We can also ask quite different questions. So, for example, what is the chance that I lose power supply? And perhaps one of the most interesting questions is that you can essentially ask what is the chance of a supply interruption, again, because of any of the issues that can lead to it. So again, it would be like a combination of other probabilities for other events in this model. So the bottom line is that we can use these types of models to build a very granular understanding of the potential risks in heat events and use that information to help with decisions about where resilience investment might be needed the most or where it might be most effective. Okay, hopefully this has given you a bit of an understanding about how we have approached some of the most technical tasks in this project and the kinds of outputs we have generated. Now I'm going to be handing over back to Alana, who is going to share a bit of information about the prototype tool we have developed using these data and models. But thanks very much, everybody.
Thanks, Stefan. So how would the audience be able to access some of the complex climate and asset modeling that you were just speaking about? It would be through the CReDo asset risk tool, which, as Dave mentioned earlier, is a web-based product. It is a prototype product that enables users to understand vulnerabilities of their assets in different climate events to help with planning, mitigations, and investment decisions. So the main way that the tool showcases this to the user is through a map, tabular numeric insights, and a collapsible tree floor mat. Just very quickly before we go on to the video demonstration, which we'll be running today, the tool will be useful for a mix of users, which includes strategic planners, emergency planners, and users in asset engineering and infrastructure design. But today we'll be focusing on our main use case for strategic planners. So we are going to be answering a number of questions within today's demo. I'm going to let the demo speak for itself. On to the next slide, and I will click play.
Hello everyone, and welcome to the demonstration of the CReDo Asset Risk Tool. There are multiple use cases the CReDo Asset Risk Tool can solve for different user types. In this demo, we're going to be looking at the strategic planner user type with the following questions. What are the likelihoods of certain climate scenarios occurring across different parts of England and Wales up to 2079? In certain extreme heat climate scenarios, how likely are my selected sites going to fail? Within a site, how likely is each asset or component to fail up to the 50th degree of detail? In a collection of sites, which site is the most likely to fail in that selected climate scenario? Within a site, which component is likely to fail in that selected climate scenario? How do different climate scenarios impact the risk of a specific site or set of sites failing comparatively? And then combining both the probability of the climate scenario happening and that site failing in the chosen scenario, what is the overall likelihood of a selected site failing? In this demo, we'll take you through 4 stages of the tool. 1. Access to the tool and logging in. 2. Adding sites and data to the tool. 3. Running the model and viewing insights from the tool. And 4. Exporting data or insights outside of the tool. Starting with access to the tool, let's say the strategic planner finds out there is a new tool that will help them access the risk of their sites and assets due to extreme heat. The user can navigate to the CReDo Extreme project page on the Anglian Water Innovation Hub, or alternatively the CReDo Extreme summary page on the Digital Twin Hub. These pages provide background information about the tool and the security and data requirements for its use. Both of these pages navigate you to the detail page on the CReDo Asset Risk tool on the Digital Twin Hub, where you can click to register to the tool by clicking the Register for Access for the CReDo Asset Risk tool link and filling out the registration form. Once your registration has been accepted and account has been created, you'll receive an email with your account details and a prompt to log into the tool and set up your multi-factor authentication. Please allow up to 2 working days for your account to be created. In your account registration email, click the Access to the CReDo Asset Risk tool link, which will direct you to the CReDo platform to access the Asset Risk tool. Remember, save this email as this is the link you'll be using every time to log into the tool. Use your account details to log into the platform. As mentioned, the user will be prompted to complete their multi-factor authentication. This is an extra layer of security to access the tool deployed in a secure environment in Daphne, the data and analytics facility for national infrastructure. Use your usual authentication application to successfully input your code. With a successful login, the user will click the button that says Protected Area, and then for this use case, the strategic planner would click Asset Risk Tool out of the menu of CReDo-based applications. Don't worry if your menu doesn't look like this on the screen. Your menu is contingent on your role-based access, so it's likely you will only have access to the CReDo Asset Risk tool. After accessing the Asset Risk tool, the user is presented with an important disclaimer around the use of the tool, which includes the historical context of the tool, what it has been designed for, a disclaimer for using insights beyond explorative uses, and a link to download the user guide containing instructions on how to use the tool. We recommend reading the user guide before you use the tool and at the very least downloading this for later. The important disclaimer pop-out is also accessible from the bottom left of the tool under Help. If the user was to decline this pop-out, they would go back to the previous menu page, but when a user accepts the important disclaimer, they get full access to the tool like so. So, welcome to the tool. To start, let's begin by adding in asset sites. There are 2 ways to add in asset sites: default site and asset data that allows a bit of customization, or by bulk data upload. Let's take a look at the default data already set up for you in the tool. By clicking Add Default Data, the tool pulls through a set of 10 different sites ready for you to use. You can customize that default data, or alternatively just leave it as it is. For fun, let's customize the data. You can't customize the site type, but you can change the site name. So let's call this site Test Water Treatment Works 1. I'm going to place this site around North London by clicking the pin dropper, I also could have done that with the latitude and longitude coordinates. Below this, you can change the variables that define the site in more detail with drop-downs that are preset as so. But for now, I'm going to leave it as it is. I can do the same process for the other 9 default sites below if I wished, but for this demo, I'm going to leave it as it is. And there we go. You have your default data ready to go. Alternatively, if you wanted to run a larger set of sites, or you have your own data that you'd like to run in the tool, you can directly upload that data via a bulk upload. To do this, the user would download the bulk data Excel template on the left-hand side of the navigation of the tool. Opening up the template in Excel looks like this. Users are recommended to use the user guide found in the original important disclaimer that we've already downloaded, or if you need to re-download that file, you can click the Help button in the left-hand corner to see that pop up again. Following the instructions in the user guide and also the How to Use tab within the template, users can upload their data in the correct format for the tool. Once you've completed this and saved that file, you are now ready to upload that data. Back in the tool, under the Excel bulk upload on the left-hand side, click Choose File and upload the new saved file you've made from the template. The upload can take up to 5 minutes, so please don't click any other part of the tool while you wait for your data to load. If there is a problem with your data file, you will see an error code, but otherwise, just be patient until you see your data load on the right-hand side of the tool, which confirms it's been uploaded successfully. A cheeky fast forward, and this is what you will see. Now, we have our data ready either from the default data choice that I showed previously or from the bulk upload, which I still have loaded here, so I'm going to use that. The user will then choose the climate scenario they want to test this against. The user chooses 3 options: how long the extreme heat event will last for, the temperature of extreme heat event over that time, and the general warming environment of the Earth. For this demonstration, let's choose a 1-day 30 to 35 degrees event in a 1.5 degree warmed environment. As a reminder, if you get stuck or would like more information, please see the user guide. Click Run Models to submit. This can take around 15 seconds to run the models depending on how much data you have, so again, just be patient. So now here you can see this is the output page and these are the results for the chosen climate scenario. At the top you can see what climate scenario the insights below are for, and then you can see the map view which shows across England and Wales the likelihood of that chosen climate scenario happening up to 2079. Whilst this is on a scale, green tends to show that it's below 25% risk of occurring, orange shows between 25% and 50% of risk of occurring, and red shows it's over 50% risk. Now the map can be zoomed in and out of to get more detail over certain areas, so you might want to do this, for example, around where your site pins are. You can also click on the pins to get an overview of the impact as a quick snapshot. If you scroll down to the table below, you can see insights about your sites that you've uploaded. So here you can see the site impact showing you the failure chance of a site if that chosen climate scenario occurred, the likelihood of the climate scenario occurring in that location of the site under the heading of climate scenario, and then the overall combined likelihood of the site failing in that scenario and the chosen climate scenario happening at the location of the site under combined climate and impact. Hover over the eyes to get a better understanding for later. The table beneath digs into more detail about the components and assets within those sites, and this can be helpful for understanding why a site might be impacted and what components are most likely to fail within that site, thus where you need to focus your attention. You can download the insight data in both Excel and PDF formats by clicking either of these buttons on each of the tables. Excel downloads will open in Excel as so, and the PDF format opens like this, which may be more useful for a presentational style format. Both tables have search, filtering, and sort functionality, so if you want to drill down onto one site, you can type it into the search bar like so, and see only the insights for that site. Or say, for example, you wanted to see which of your sites had the highest chance of failure if that climate scenario was to happen, you can click here to sort this by the site impact column by highest failure chance. The search, filtering, and sort functionality can be very useful for the insights around things such as most likely to or least likely to with regards to failure, and then pinpointing the data that you might want to delve deeper into. The filtering and sorting can be then downloaded exactly as seen in the same way as before by clicking these buttons. The Excel and PDF documents will then just show the filtered or sorted data. If you further scroll down the page, you can get to the expandable and collapsible tree format, where you can see all the data at once and delve deeper into the components of the site and assets within those sites in a logical way. Let's take this site. We can expand the data into a substantial amount of detail to see what components of the asset and site are likely to fail in that chosen scenario. This is helpful for understanding how best to implement mitigation strategies, as you can see what is going to need protecting or replacing over other parts and where they sit in the site with their dependencies. It's important to note that the tree format is written in JSON and thus is preset for analytical work in that format. This means where it says %fail, it puts the percentage into decimal format. And bool fail means the boolean of that percentage, which is either 0 or 1 based on rounding of that percentage. Now you may say you wanted to compare against different climate scenarios for a specific site. Let me return to the input page by clicking the Home button at the top of the page. This will open a new tab to make sure you don't lose your current scenario analysis, as the tool doesn't store any data for security. Once back at the input page, you can also duplicate this tab up the top here to see even more scenarios to compare. Taking the same steps as we did before, we can load in the bulk data or adapt to the default data and then choose a climate scenario on the left-hand navigation. I want to compare how difference in length of time of the climate event has an impact on the sites. So for this one, I'm going to run the same data file as we used before for the event of 1 day of a 30 to 35 degree climate event with a 1.5 degree warmer world. I click Run Models again, and once it's loaded, this is what we see. Then for the next tab, I choose a scenario of 3 days in a 30 to 35 degree climate event in a 3 degree warmer world. And this is what we see. By clicking between the tabs, I can compare the likelihood of that climate scenario occurring over England and Wales, in particular at my site locations, the likelihood of that site failing in that given climate scenario, and then the combined likelihood of it occurring overall. Looking at site AASEAB, we can see the insights for the 1 day at 30 to 35 degree weather event in a 1 degree warmer world scenario. Now we can compare these to the 3 day 30 to 35 degree scenario in the 3 degree warmer world and see how they differ. Seeing here that the likelihood of substantial site impact is higher, but the likelihood of that climate scenario occurring is actually much lower, and thus the actual combined likelihood of the site being substantially impacted by that 3 day scenario is lower than the 1 day scenario, telling us we need to care more about the mitigation strategies for the 1 day scenario. Here we can see for the 3 day scenario, the site at highest risk of substantial impact is AASEAK. But for the 1 day scenario, the site at highest risk of impact is UUWWP. However, when we compare the combined risk, we actually find that UUWWP isn't as risky, and that actually AASEAK is the site at highest risk of substantial impact across all the sites. Here, the strategic planner may want to look into detail of the AASEAK site through the asset and component data in the asset table and the tree format below, and then utilise the sort and filter functions to delve further into detail to understand where best to propose mitigation strategies. These types of insights can be very helpful for users to see not only what sites, assets and components are at risk in certain scenarios, but also what to prioritise when planning mitigation strategies. Thank you for listening, and we hope you enjoy the tool.
And I just want to say thank you to my colleague Holly, who narrated the demo video and is our product lead for CReDo. If anyone has any questions on CReDo from a product perspective, she's absolutely the person to speak to. But now I'll hand it over to my colleague Jethro from CMCL, and he will discuss digital twinning.
Hi everyone, I'm Jethro Aykroyd from CMCL, and my team and I have been responsible for the implementation of the digital twinning aspects of CReDo. So the asset risk tool allows us to quantify the risks of assets failing in given locations with respect to an extreme heat weather event. We can identify which assets are vulnerable, and we can use the information provided by the model to support decisions about how to increase the resilience of individual assets. And that focus on individual assets is where the asset risk tool leaves off. However, the assets do not exist in isolation. They exist as part of wider infrastructure networks, which are themselves part of a connected infrastructure network. And this is important because a failure in one network can propagate through the others. So these infrastructure interdependencies and the increase in the level of cascading risk with climate change are exactly the concerns raised by the Climate Change Committee. And historically, these risks have not been addressed because the interdependencies between the infrastructure networks are not visible. And addressing these risks requires some form of data sharing. So in an ideal world, this would be implemented in a way that allows you to ensure that sensitive information remains protected while benefiting from the insights calculated on the basis of the overall connected network. And this is exactly what the digital twinning aspects of CReDo seek to make possible. Delivering the ability to share data securely to optimize decision-making across the infrastructure networks is where we bring digital twinning into the picture. CReDo uses a distributed architecture that allows asset owners to retain control of their data assets while securely sharing it with CReDo. And this data sharing is not the same as open data. We've developed a data license that allows CReDo controlled access to information about the assets. And subject to this license, CReDo uses a secure compute environment to combine a temporary copy of the data describing the assets with data describing the weather events with the models that Stefan was describing to analyze the impact on the overall connected network. CReDo is then able to return these insights to the data providers to describe the impact on their assets. And then, subject to a suitable data sharing agreement that defines who can see what, it's possible to provide additional information, additional types of insights and additional services. For example, decision support and automated reporting. And the extreme heat weather data and the models that have been described today are examples of the components used by CReDo. They were developed as part of the CReDo digital twin and are shared by the CReDo asset risk tool. So this means that any data that you prepare for use with the asset risk tool is integration ready for use with the digital twin. And to reiterate, this distributed architecture segregates the information provided by each data provider and allows control over who can see what insights. The insights are calculated on the basis of the overall connected network, and the data are only aggregated in the secure compute environment and only for the duration of the calculations needed to generate the insights. So the combination of the data sharing license, the provision of a secure compute environment by the Science and Technologies Facility Council, and the design of the digital twin is such that users are able to share data and receive and retrieve insights without compromising the security of their data assets. One of the technical challenges to CReDo is to enable interoperability between the data and the tools that are required. And we achieve this using an internal data structure based on the use of ontologies to represent the information as a knowledge graph. The ontologies are hierarchical. We define concepts and relationships that apply throughout CReDo at the top of this hierarchy. And as we move further down, we then define specializations at the lower levels of the hierarchy. We've introduced an intermediate level where we define things that apply across sectors. For example, the concepts of water pumping station, water recycling center, and water treatment works, which are meaningful to multiple asset owners from the water sector. The ontologies right at the bottom define the specializations of the concepts and the relationships that are specific to each asset owner. This approach is extensible because it's straightforward to add new ontologies to define new specializations as we extend CReDo to describe new asset owners. It also confers interoperability in the sense that by writing the software used by CReDo in terms of the higher level ontologies, CReDo can use the same code to process data for each infrastructure network without the need to change the code when extending CReDo by adding new asset owners. The approach, importantly, also maximizes outward compatibility because it permits the possibility of mapping from other data sources, from other data models into CReDo, including the possibility of mapping from whatever format is currently used by asset owners. And we believe this is important because, as I'm sure we all appreciate, digitalization is a journey and we need to cater to parties that are at different places on that journey. Beg your pardon, something has gone wrong with my slide navigating. I just wanted to show you a picture of what some of the ontologies look like in order to give you an idea of some of the complexity. And I want to emphasize that the complexity isn't the size of the ontology, it's in making sure that the relationships are correct and support the practical implementation and use of CReDo. So on the subject of the practical use of CReDo, I just wanted to give you a taste of what CReDo might look like in the future. In the demonstration of the asset risk tool, we focused on an extreme heat scenario. So here, I'm going to focus on a flood scenario. This example uses synthetic asset data and grants us permission to see data from multiple asset networks. So from a synthetic water network, a synthetic power network, and a synthetic telecoms network. Underlying this example is a model that calculates the response of the assets in the combined network to a flood hazard, where the red, orange, and grey borders around the assets on screen indicate different types of resilience problem. The interface allows users to see the same granular detail of information about the assets and has the same ability to summarize information across scenarios that you saw in the demonstration of the asset risk tool. The difference in this case being that these insights are calculated on the basis of the overall connected network. And with this, I believe it's time to take a quick break, and I'm going to hand back to Leah. Thank you.
Thank you, Jethro, and thank you to all of our presenters so far for a great presentation. So we are just going to go to a quick break. We will be coming back to hear about some lessons learned from Tom and what the next steps for the project are. So please do keep putting in your questions throughout the break. My colleague Kira will also pop a poll into the chat about how engaging you found today's session so far. You can answer this at the end or you can answer it in your break, but we really do appreciate if you could give it an answer for us. So the time is now 11:05. We'll have a 10-minute break and return at 11:15. Thanks, everyone. Okay, so it's 11:15. So we'll go back to the presentation now, and as mentioned, we'll be handing over to Tom to talk us through some lessons and the next steps for the projects.
Good morning, everyone. My name is Tom Burgoyne. I'm Anglian Water's Asset Systems Specialist. This role has me working across the carbon neutrality and asset intelligence teams. In the former, I'm looking at climate modelling, which obviously puts me front and centre in this piece of work and has me as the technical lead for Anglian, but also energy efficiency and maybe straying into process emissions and circular economy, etc. In the latter, I'm actually looking at the systems which our asset data sits within and trying to make those work more effectively together. So in this section, I'm going to be looking backwards towards some lessons learned for the project, and then a little bit of context, skim through 3 slides, and then come to the future look. So here in the lessons learned section, thanks for the colleagues for setting out such a good presentation so far, but obviously with any project, there are sometimes some road bumps you have to get over, and I'm just going to try and move across some of these bullet points. So one of the things that's, I guess, very present at the moment for myself and my colleague Richard Buckingham is how to actually embed this tool, make it useful to Anglian Water. So in our design alliance, we actually currently ask the question of is the designs they're putting in for maybe new water boosters or what have you, whether climate resilience has been taken into consideration. And it's relatively a tick box exercise at the moment, and we're hoping to actually use this tool to make it slightly more real. And so we'll be getting those teams to actually input their data, the design data, and the location of the asset into this tool, and to understand under given scenarios what the risk is actually going to be to that asset and whether we're happy with that risk. And perhaps if the risk is too high, we may ask for them to go back and try and refine the design, bring in some of those mitigations, be it extra ventilation, shading, or what have you. Now, that's not a small piece of work, and it's also not just a small piece of work for Anglian, but if this is going to be worked across the entire industry, then there will be work for Anglian to help guide people through that process. Looking down the list as well, UAT, so that's user acceptance tests. That is where we are checking that the application is working the way that it wants to, and inevitably that's going to come at the end of the project. But with any slips or delays that you have through the project, it begins eating into that UAT time. So I think it needs to be absolutely sacrosanct, a ring-fenced period of time at the back end of the project to do the UAT. We had to rush through that, and in fact, we're even doing a little bit of UAT post-project at the moment. So making sure that people actually have that time within any project that they're doing is essential. Continuing down the list, we find SMEs, so subject matter experts. Stefan mentioned the reliance we have through the expert elicitation on experts getting the tacit information from their heads into these models. But clearly there is a day job everyone is trying to commit to, and actually being able to find the time to have a relatively abstract conversation about things that might happen in the future is relatively challenging. And so I think we were successful in this project, but I think it's understanding that balance between the day job and actually encouraging people to look to the future, look to these potential challenges in the future to actually be able to get the information that we need from them. The next point I wanted to raise is around the alignment of calendars. So this project you've maybe picked up on is part of an ecosystem of other projects. And with that, there was demand on the time of the technical resources and indeed milestones within other projects. So SIF here stands for the Strategic Innovation Fund. That is the Ofgem fund, which has been building various pieces of the CReDo infrastructure through being led by UK Power Networks. And that has had innovation funding milestones on the way through, which we had to try and dovetail in with, and also the academic calendar as well, in terms of the many researchers that we have employed on this project to help. And those put tensions on our programme, and I think having a better understanding of those ahead of time would be very useful. We're working across, we're a very distributed team. We very rarely actually get together face to face. And with that, particularly the technical development was actually being done from at least two SCFC and CMCL, with the two kind of key leads, with CBC adding a third, I guess. So that distributed team, both geographically and working together, required an agile way of working. So we brought in Jira, which is a relatively familiar tool for managing agile projects, but notably we brought it in part way through the project. I highly recommend bringing that in at the start of the project, because learning how to use new tool during the in-flight project can be a bit of a challenge. Stefan's basically already covered this one already, but the de-biased climate data, so we maybe naively thought that the CP18 data was kind of ready to go. But actually, when we realised that it needed this extra kind of manipulation to get us closer to reality, we thought about trying to tackle that ourselves. But thankfully, Bristol University had already done some work and covered that ground for us. They had done it at 11 kilometre squares. We were hoping to get down to 2.2 kilometre squares, but based on the challenge that would present, we worked with the 11 kilometre squares that were available and then synthesised what we needed from that for our extreme heat scenarios. So just, yeah, really understanding some of the technical challenges of the subject matter at the very offset of the project is absolutely essential. And the final one here, which is very relevant, particularly as I was helping on the Excel template for bringing the data in and tying back to my work in asset intelligence. The semantics of how the asset data is recorded in each of the water companies, they hold them in all sorts of different formats. One of the things that's very critical for this particular project was understanding assets being housed within other assets, so pumps within a pump hall. And we needed to understand the ventilation for the pump hall. We needed to understand the building fabric of that pump hall and which pumps were inside said pump hall. Now, this kind of information doesn't tend to naturally sit within the asset data structures from the partner organisations that we were working with, or indeed within Anglian. And so trying to guide people to actually hold their data in a more comprehensive way is kind of like a wider strategic point to be made here. But moving on, so just I'm going to skim through these slides really, but just to understand this wider CReDo goal. So we've been talking about the Catalyst funded project, which is a piece of this puzzle, but the wider CReDo project has a USP around connecting data. So looking at that system cascade, being able to share the data across the siloed organizations to ultimately bring together insights to make better decisions and improve the reporting across the connected infrastructure providers. And clearly using knowledge graphs, etc., to kind of coordinate all of this information will make for better strategic resilience planning. All the great things that have been explained in the earlier sections of this presentation. Putting it into context, we have the CReDo asset risk tool, which is on the left-hand side here. We brought in the extreme heat climate stressor. That's the data that was brought for this particular challenge. We've mentioned flooding was already within the wider CReDo platform. And we built this web app. We built this tool to allow people to look at pins in a map, assets in different locations in the UK. Clearly, this is a prototype, and we are trying to make sure we can move through into the slightly more advanced stuff that Jethro was just talking about, where we actually start joining those pins together to actually really understand the dependencies. One of the key underpinnings of this project was to make sure that we were integration ready, and we actually reused many of the components of the core CReDo platform to facilitate the web app that we have generated. And then ultimately, this will all lead through to a decision support tool to actually empower the strategic planners in their decision making. Sorry, I missed that click. So now just to give a wider context again, so sorry, this is a very busy diagram. I'm not expecting you to read everything on it, but this is the kind of wide ecosystem being described by CReDo. The little green numbered circles on there, that's actually referring to the off-GEM funded projects called CReDo Plus Beta. This has now reached the third stage of its innovation funding and has just mobilized, having been successful in gaining that funding for a 4-year project, I think it is, where they're going to try and build on the kind of core in the center, that digital twin technology. They're going to be bringing in storm data. So clearly with pylons traversing the countryside and the wind load on those, that's of great interest to the power sector, maybe less so to the water sector, but we will see how that potentially gets tied in with our work. Again, they'll be building asset risk models associated with that, understanding the system cascade and bringing that decision intelligence to play to help answer questions in their industry. There are various improvements that we're looking to use for the graphical interface that will be coming through that project as well. And ultimately tackling some of these thorny data sharing issues as we move into a wider selection of infrastructure providers. You might notice there at the top as well that gas owner has come into play. So there are gas network operators as well as electricity network operators now working together. And that becomes relevant to something I'll come to later. And ultimately, this is to support all the decision makers. Now, I mentioned before, this is like puzzle pieces. So the SIF project will be filling in some of these blanks and kind of helping with a number of these sections. But what I'm going to bring us to next is the plan that we have for CReDo in the water industry going forward. So we've just pulled together a bid proposal called Streamlining Climate Adaptation for our next CReDo step. We had our Q&A a few days ago, which was very interesting. Hopefully we will get through stage 1 and maybe we can convince some of the water sector members to join us in our endeavour. A few people have in principle joined in already, so our original partners, which were Affinity and United Utilities, but alongside that, Northumberland, Yorkshire and Thames have all actually expressed an interest to actually be part of this project going forwards. This one we're going to try and dovetail in with the Strategic Innovation Fund mentioned before. We would probably look at this being a 3-year project. And our focus, our new climate stressor, would actually be soil moisture deficit. So if you kind of think about flooding making the soil wet and extreme heat making it dry, it's a fairly natural progression to understanding about the soil moisture deficit and how ground movements will then start affecting our underground assets. So We've been primarily focusing on the kind of nodes in our network, the kind of water boosters, the water treatment works, etc. But this stage of the project, we're hoping to now really join the dots to move into the core CReDo platform and understand those cascade failures, but also understand the challenges presented by the climate to things like climate vulnerable mains. Now, there are pieces of work already being progressed in Anglian, I think Yorkshire as well, which is why we're so pleased to have them at the table around the climate vulnerable mains, which we'll be trying to bring through this same kind of approach into the CReDo project. You may also notice Stream mentioned down the bottom right. So clearly CReDo has the requirement for data sharing, and Stream is the mechanism that is being used for sharing data within the water sector. They've traditionally focused more on the open data side, and as been mentioned before, we're maybe into slightly more of the closed or closer to the closed end of the spectrum. So I think will be a really interesting use case to test some of their ideas and mechanisms to make sure that we can actually integrate their thinking into the CReDo data sharing platform as well. And the final point to make is around previously CReDo has been looking more at a kind of an acute asset failure. So maybe a kiosk gets heated up in the sun, becomes very hot, and the inverter with inside it that's sited inside it trips out. This particular project, we're actually going to start looking at more kind of long-term impacts on assets, and particularly those underground assets in more of an asset deterioration model perspective. So there's various teams across the water sector already looking at asset deterioration. And there's actually a high-level project looking to try and standardize how asset types are recognized and their deterioration models alongside that. So we're going to try and leverage that and make sure that we have a climate variable within the asset deterioration to understand how maybe a water main that we at one time believed would last for 20 years, now it's only going to last for 15 years because it is being put through the mill of soil moisture deficit and ground movements, etc. So this is, I guess, a call to action. As I say, if anyone would be interested in finding out more or contributing to this bid, hopefully we'll get through stage 1. And if we are, then your support for getting through stage 2 would be really, really good. I'm going to hand back now to Lee, I think, who's going to coordinate the questions and answers. So if you've got any questions, please do keep adding them to the chat, and hopefully we will be able to cover off the detail there. But thank you very much for your time.
Thank you, Tom. So we're now going to move into the Q&A portion of the session. So if I could get all the presenters to pop on their screens and their microphones, we'll delve into some questions. We do accept further questions, so please do keep putting your thoughts in the chat as they come to you if you think of any new ones. I'm just going to stop sharing my screen so you can see our lovely presenters as well as possible. Perfect. Okay, so question number 1 from Cara, who wants to know on the 2 and 3 day scenarios, is the risk of asset failure shown on a daily basis?
So I think I can take on this one. I'll invite my colleagues also to add to what I'm going to say. I think the short answer to it is no right now, but we in CReDo, we're aware that users might want to understand risk from or under different lenses. So for example, what we have so far, it's more focused on those events I was mentioning earlier as a single kind of like event that's static on time, if you like. But we have worked in the past with the flood data, and we have the ambition to explore this also for heat and potentially other phenomena when we start developing those about events as something that develop over time, for example, hourly or daily, etc. So I think in the future, this is something we'll definitely be looking into, and hopefully will provide also a range of outputs that support these kinds of use cases and these kinds of different ways to look at data and risk. One key thing to remember here is that finding the right data to be able to represent this sort of like different views of the risk and the data can be complicated, and processing that data in a way that's usable to be able to answer these kinds of questions is challenging. It's a challenge we'll explore, but it's worth understanding that there is a lot of complexity and work that will need to be done, which is why we focused on something simpler in this alpha kind of catalyst project at the moment.
Perfect, thank you, Stefan. And while you have your mic on, there's another question for you from Adil, who wants to ask, is there a plan in the future to replicate it for process structure? For example, chemical storage tanks. High temperatures can alter the stability and efficacy of chemicals, which can cause a site to fail.
Great, thanks for that question, Adil, too. I think the answer is yes, potentially yes. So again, just remembering this catalyst project is, in my mind, is an early alpha kind of project. So we haven't necessarily developed models and approaches for all the kinds of vulnerabilities we have identified. And we're also aware that there's probably things that we don't even know about, and that would come out of speaking to a wider range of water companies and a wider range of experts, etc. So I think, considering that what we have developed so far is not the final version of things, we're very likely to just develop new models for new kinds of risks. And this could very well be one of those things. We've got the base methodology to be able to represent these sort of things, like, for example, the chemical storage problem that you mentioned there, which could be done through, again, expert elicitation, or potentially, because this is physical chemistry and it's governed by well-known laws, etc. It could be that we can even use data or known equations to build models around these kinds of processes. So I think, yes, potentially in the future, it could be very much these kinds of things that we also look to expand in future phases.
Perfect, thank you. Alana, question for you from Tony, who wants to ask, any plans to expand the tool to incorporate all of Scotland? Only southern Scotland was covered by that map that you show at the start.
Thanks, Tony. And yes, good eye. So we, the CReDo team certainly has ambition to cover the whole of Scotland. Currently, or to date, we've been funded primarily through innovation funding from the regulators Ofgem and Ofwat, which have a jurisdiction over England and Wales, hence why we focus on that data. However, we are keen to have conversations, as Tom mentioned earlier in his lessons learned. It's a function of being able to access experts on top of their day job. However, we're very keen. And as part of our SIF funded, that's the Ofgem funded beta project, which will be kicking off in January, we are engaging with power networks within Scotland. So there is that possibility in order to build scale, hopefully going forward, should CReDo move into the Transform project. But definitely reach out. We're keen to have a conversation on how we can get insights from Scotland and make them available via CReDo.
Perfect, thank you. So question from Ash, who wants to know about cybersecurity. So he has said, have you considered the risk of an external malicious event like this in conjunction with an adverse heat-based climate event on operational assets and datacom continuity? So at a lower temp and external risk. The electric vehicle sector, though nascent and in its formative years, faces numerous challenges, including concerns related to cybersecurity.
Shall I take that one? I mean, I think it's a great question, Ash. I think the first thing we should say is that the focus of the CReDo, the current CReDo use case, is on climate adaptation. But the approach that we have developed in terms of being able to use shared data to represent the networks and the connectivity of the overall connected network, combined with the modeling approach that we're developing, means that I think this is something that we could do technically, but we're not at that point yet. And as I say, our current use case and the support we're receiving from Ofgem and Ofwat is directed towards climate resilience.
Perfect. Thank you, Jeffro. Okay, question for Tom from Judith. In terms of looking at soil moisture deficit element, she missed the timescale on that. Would you be able to just repeat that for us?
Yeah, so timescale in terms of when we're going to be trying to look at that element in that perspective. Hopefully, if we get the Transform funding, we'll be bringing that in sort of the middle of next year, and we'll be working across 3 years in line with the SIF program to actually try and understand that particular problem. But we're actually building on work that's already been done, so we're hoping that actually that will come in more quickly. In terms of timescale, in terms of the impact on our assets through soil moisture deficits, then that will be very much informed by changing lifespans of assets. And I can't necessarily predict what that is. It's not an area I'm particularly got a lot of information on, so I can't answer it if it's the second interpretation of that question. Sorry.
Totally fine. Thank you, Tom. So question again for Alana from Chris, who said, really interesting stuff. Have you considered how this can be used across other industries, such as considering climate impact on supply chain in agriculture or use in climate adaptation, mitigation plans and reporting?
Thanks for the question. So absolutely, part of the work we're doing is considering other sectors. At the moment, the additional sector we're exploring is transport, as it closely relates to some of the key challenges we're looking to address within water. However, part of expansion to CReDo and building that scale that we need to understand climate resilience across the country is incorporating other sectors such as agriculture. So it's on the to-do list. And we'd be keen to, explore opportunities to get a better understanding of how those sectors can be incorporated.
Perfect. Thank you, Alana. Okay, so question for Stefan. I think, again, someone maybe just missed some information that you'd given, but they just want to ask, does CReDo allow for actual asset condition data and therefore impact on failure probabilities?
So I think one of the main points to make here is that the way we approach modeling and we integrate it into CReDo allows to expand what the models do. So again, I want to reiterate the current version of the models we have is not necessarily the final version of the models we would build. So at the moment, the answer is they do not take into account asset condition. We know this is an important thing. So it could be that this is a variable that we extend in the future to consider. One of the key reasons, again, was like, what is the compelling thing we can do within the timelines of an early alpha kind of project? And we thought the other variables we've considered, for example, in motors, the environment in which they operate and what is the demand level at that point, were key ones that we could tackle more easily. But asset condition could be something that we definitely take into account in the future, assuming that the right data we need is available in asset owner organizations.
Perfect.
Yeah, if I could come in on that as well, if possible. So we have actually got various bits of condition-based monitoring information, and we were beginning to draw some interesting deterministic relations there. As Stefan said, we only had a limited amount of time and resources on this one, and we were pursuing that expert elicitation as the primary source. But yeah, absolutely, we want to try and bring some of this measurement and actual understanding of cause and effect data through into the models. And the fact that you can end up with probabilities coming from that approach as well means it's just kind of a lift and shift. You can add that into the framework that we already have in place. And actually, there's some work that Thames are looking to try and get funding for that we would be a partner on, looking at these more kind of actual scale models, understanding the actual risk, the actual percentage risks, rather than just the expert elicited risks. And so again, we understand that we could port that information directly into our models, so that ends up being a mix both of expert elicitation and deterministic models. Yeah.
Perfect, thank you, Tom. Helen just added in the comments that she was just thinking that this would be a good way to determine where investment is needed in organisations. Perfect. So there's been lots of talk of data, of course, as part of this. So I'm just wondering myself, do you have any plans to work with kind of those open data kind of organisations, like such as Stream, for example? Do you see there kind of being a collaboration opportunity there? That's just for anybody who wants to answer.
Yeah, I can come in on that. Lana might be able to help me out as well. But yeah, so we're absolutely going to use Stream as one of the vehicles for our data sharing going forwards. Well, I actually got a workshop, I think, in maybe a couple of weeks' time, just to kind of get the ball rolling on that. Now, there is actually some ground being covered in the energy sector as well. So the data sharing infrastructure is going on. So hopefully our alignment with the SIF project will actually start unlocking things around trust frameworks, etc., on how they're actually tackling that challenge in the energy sector, and Stream are fully aware of that work as well. They're again quite complementary pieces of work, but this project hopefully will act as a bridge between both of those data sharing initiatives, a test of both almost at the same time, which would hopefully be quite interesting. I know Alana went to a conference on behalf of the project team. I don't know if she wants to add anything or not to that response.
Yeah, just to say that initiatives like Stream, in this case, I'll talk about Stream, are really important in terms of enabling CReDo. So, you know, we're all working within the data sharing ecosystem. Stream and other open data sharing projects are looking at creating open data that's easily accessible. CReDo does something complementary to that, which is create a closed and distributed architecture in order to get insights which require at times open data in order to get that. So we really believe in developing the overall ecosystem of data sharing infrastructure so that all initiatives can really improve the outcomes for the water sector and across sectors. So yeah, we're both looking at CReDo as a use case for Stream, but also Stream as a use case for CReDo. So there's that interdependency kind of permeating through how we believe we should be working across the sector and cross sector.
Perfect, thank you, Alana. Okay, and a final audience question from Claire is there an option to include Environment Agency data, for example, river water quality, dilution impact in high temperature scenarios?
So that's an interesting one. I think we've certainly got the EA as one of the people on our list of people to try and bring into the fold for CReDo, absolutely. With their assets initially thought of more as their kind of infrastructure assets, but also recognizing the waterways around the country being conduits for water, and it absolutely part of that system of systems that we'd be wanting to look into. That was maybe more pitched at the idea of them us abstracting from the environment and returning to the environment, rather than necessarily the impact of heat on the rivers themselves. But I certainly think the actual the models that could be built on the foundations that we are building could potentially start addressing some of those kind of questions, even if they weren't necessarily the prime focus of the project at the moment. But yes, I mean, one of the really exciting things about the CReDo projects is how many directions you could actually go in, be it to different sectors, different climate scenarios, scaling up to Scotland, you know, all of this kind of dimensions that we can work in, as well as the different use cases that could ultimately be supported. So yeah, a really interesting question. Thanks, Claire.
Perfect, thank you, Tom. So just some more questions that have come in privately is, how can you validate the outputs of models built in this way, meaning expert elicitation? I think that's one for Stefan.
Great, thanks for that question again. So this is a complex question. It's obviously important. There are different ways in which we can approach validation to the model outputs. So there is an informal side to it. So the first thing to say is expert elicitation sounds like something that's very simple, and conceptually it is, but there is a lot of mathematical nuance in the background. So these methods have been developed and tested and used for decades now by expert statisticians and mathematicians. So there is an element in just following best practice, and the methodology gives you already a certain level of informal soft validation. Then obviously you can do more formal validation, and there are essentially two options for this. Which ones you use is a bit depending on what's available. So the first one would be, for example, in the context of heat events, if we had a good historical data set that says these kinds of machines have failed or have developed these kinds of faults in these previous past events, then you could compare that existing data with your model outputs, and you can apply the right mathematical methodologies to validate and refine your outputs. Obviously, if you had a lot of these data, instead of using expert elicitation, you would probably go ahead and use that data to build your models, but that would be a source of validation. The problem is, as I said, expert elicitation you typically use when you don't necessarily have that data because it doesn't exist. So the other option to validate is pretty much carry on or doing more elicitation, in the sense that you would build your models, you have outputs, and then you talk again with the experts to come to a consensus about whether the outputs of the models are reasonable or not, and refine based on that. So if you think about it, it's like when you trust experts on your daily life about many other things. So for example, you go to see your GP because you have some health issues, you describe some symptoms, they give you a diagnosis, and you hopefully trust your GP in that expert elicitation assessment of your condition without necessarily getting, for example, a blood test or anything formal. So that's sort of like different ways we can validate these kinds of models depending on what's available. Hopefully that answers the question. Thanks.
Perfect, Stefan, thank you. And so we've already had a few questions about kind of specific potential use cases for this model, but how flexible actually is it? Can you basically build any type of model for any type of process?
So I think the question, this is a really interesting question. Again, I think the short answer is, or what I like to say when I get this question is, as long as you can get a range of experts that can make reasonable inferences, that can make reasonable guesses about what you're trying to represent. So for example, in our case, the potential fault of equipment when they're under extreme heat conditions, then the answer is yes. So the methodology is very flexible and can do anything as long as you can get the right answers from the experts, I guess. And the other thing to mention is that it's also possible to combine expert elicitation with more traditional methods. So if you have a bit of data, but you don't think it's enough to build a model, then you could use both the existing data you have and some expert elicitation, combine both, and hopefully get the best of both worlds as well in that kind of situation.
Perfect, thank you, Stefan. And then Raj just wanted to ask, where will the SIF data project actually be published?
Hi, Leah. Yeah, I answered Raj in the chat. So the information from the SIF Alpha project has already been published on the Energy Networks Association web portal. So I've linked in the chat. But for those who are interested in some of our cross-sector use cases and some of the challenges we're addressing in both energy and telecoms that will impact on water, we do have a webinar on the 21st of November, which is different content than today. So we'll be, although Anglian Water will certainly be a part of that webinar, where we'll begin to talk a bit more about the cross-sector use case and how we intend to collaborate across the three sectors in the future development of CReDo. So I've dropped the link into that webinar, and we would welcome everyone to attend.
Perfect, thank you, Alana. And sorry, I hadn't realised you'd answered that in the chat.
No, no worries at all.
Perfect. Okay, so we've just had another question in from Cara too, who wants to ask, could you work with e.g. pump manufacturers to test their products in extreme heat conditions to validate model assumptions?
Yeah, I can come in on that one. So we actually did talk to ABB, which is a key supplier to Anglian Water, about the motors and the inverters. Now, if we're thinking about pumps themselves, you can have pumps which above ground, they may not suffer quite so much, but the gearboxes and the motors that are attached to them would. And if they are all inbuilt in one thing, so the pump manufacturer is providing it as a kind of like a single unit, they tend to actually be submersed and so slightly less impacted by the ambient temperatures outside. So it wasn't an area of immediate focus for us on the project for those reasons. But yes, absolutely, this idea of going to the manufacturers and getting some more of that kind of deterministic data. I mean, it was helping us with that structural elicitation piece that Stefan said, us deciding which were the thresholds, which were the buckets of temperatures that we would want to actually look at, was actually informed by the manufacturer's recommendations about where assets start getting a bit stressed by these temperatures. So yeah, it's been part of the project. It will continue to be part of the project. Yeah.
Perfect. Thank you, Tom. And the question from John, who wants to ask, how can we guarantee the people side of the take-up on these really great solutions? Can we use tributary now to guarantee the people side in 2024 so that we have no distractions left by the time the big decarbonisation build begins in AMP8? That's open to anybody who has some thoughts on that.
Yeah, I can try and come in on that. I think it's maybe pointing towards some of the reasons for being here on the Spring webinar in the first place is just to kind of raise the profile of the work to make people aware of it. There's other work being done by the central CReDo team as well to understand how to kind of productionize or productize this CReDo ecosystem itself so that people can actually gain a kind of more formal access to it rather than through these innovation funds, etc. But in terms of the idea of being distracted by the many other challenges that are out there at the moment, I think that's just the volatile world that we're in at the moment. There are many competing needs. I'm hoping that some of the kind of USB of CReDo, however, does place it quite well, as was alluded to before, for actually potentially solving a wider cross-section of questions. So maybe that will cut through the noise as saying this is actually a really powerful solution to answer as an enabler for many questions being answered. But yeah, I'm not sure that totally answers your question, but it's quite a big question. If anyone else can come in if they want to add.
Nope. Perfect. Okay, thank you, Tom. Okay, so I have a question, if that's okay. I just would like to know a little bit more about the process of building this, and if you encountered, I know it's a prototype at the moment, but if you kind of tried anything that you thought would work and it didn't work, or it didn't work as well as you expected it to, or if you potentially tried something that you didn't think was going to work that great and it ended up being a really great way of doing things.
I don't mind revisiting my lessons learned. Really, the way we organise data in any infrastructure provider, let alone just those within the water industry. I think we naively thought people would be able to just pull together information on assets being within buildings and this, that, and the other. And you know, when it came to the crunch, that's actually quite hard for people to pull together. Quite hard it was mainly felt to me within Anglian Water to actually pull that information together. So having clarity about how we can describe those assets and how that can be captured across the entire water industry and beyond was something that was just a lot harder than I expected it to be in the first instance. But yeah, but there's numerous other things. So perhaps someone else can maybe add to an answer to that.
Perhaps I can chip in. I mean, I think on the digital twinning side, and certainly perhaps also on the modelling side, on the digital twinning side, the ideas underlying the architecture of CReDo are something that my colleagues and I, and alongside research colleagues at some of the universities, have been playing with for a number of years. So when we were first confronted with CReDo as a use case, my first reaction was, I know how to solve that problem. And I think we then worked as part of the wider CReDo team to put together bits and pieces of technology that we knew and understood in a slightly new way that allowed us to create this sort of connected digital twinning approach that CReDo took. I think looking at the approach to the modelling and the expert elicitation, again, this was taking something that was, it had a framework, it was understood how to do it, And it was working out how to scale that up and apply it in a more systematic way that is one of the keys to achieving the scale that the CReDo use case would demand.
Perfect. Thank you, Jeffro. And I think we've got time for one last question. So how can I actually begin to share data in order to join CReDo while protecting the confidentiality of the information that I provide?
I think that's perhaps a question for me as well. I think the key to how we protect the information stems from the distributed architecture. What we've tried to do is develop something that can keep data from different asset owners on separate servers, potentially within their own IT ring fences. And then working with the data licensing approach that I described, we have a legal framework that allows the sharing of the data. Then working with colleagues at the Science and Technologies Facility Council, with people representing cybersecurity experts, we have a secure technical solution that allows the models that Stefan has developed to access the data, processing the models in a trusted research environment, not maintaining a copy of that data in the central environment, but then sending insights back to the same location that the data came from. So sending insights back to the servers used to host the data, either a server per asset owner or potentially a server still within the IT secure IT zone of individual asset owners. So that's the technical answer to how we would keep the data secure. I wonder if someone wants to chip in on how prospective partners might join CReDo.
Yeah, I can have a go. So particularly from the water industry side of the equation, which is I guess more relevant here. Getting involved in the Transform project itself would be absolutely a great way of getting more involved. But even in a more kind of periphery way, the use case for Stream, I know Stream is very well represented across the water industry partners, and so that will then begin kind of opening the door to the CReDo ecosystem as well, or at least getting their opinions and needs heard, be that from a cybersecurity or any of the other kind of use case directions that we might be taking things in. So I think that's probably the best way for the water sector. I don't know whether CBC wants to kind of talk about how we're making inroads into other sectors or maybe the energy sector.
Yeah, I'll just pick up on that. Once we kick off on the SIF-funded beta project, which once again is happening in January, we'll be reestablishing a resilience working group, which is something that we ran during the course of the Alpha project to bring energy sector innovation projects together so that we could build that shared understanding on where we can build resilience using different elements from our different projects. We intend to run the same thing throughout the beta project, but make it cross-sector. So there will be an opportunity for individuals to join that group regardless of the sector that they represent, so that we can start figuring out how we can share lessons from CReDo and start to embed it in business as usual going forward. But this is quite a few years off at this stage, but we welcome early input and early engagement.
Perfect. Thank you, Alana. One final very quick question from Ash is, focus is key in DT, but wondering if power quality should be added.
I'll maybe try and chip in from my energy background on that. I mean, that's actually a very big question. Because you can talk about water quality and, are we putting the right pressures into a water network, as well as any of the kind of harmonics that might be coming through from the power networks, etc. So that is another whole magnitude greater of complexity for adding that kind of thing in. But again, the framework that we're putting in place hopefully would allow us to build in the future in different directions, and perhaps power quality would be one of them that comes. And again, the work that's going on the other side of the fence in the energy sector, one for them maybe to kind of take away and consider how far down that road they can take the CReDo project.
Perfect. Thank you, Tom. Okay, great. So I think that wraps up today's session. So thank you to everybody who has taken time out of their day to join us today. We do hope you found it valuable. Thanks again to the team from Anglian Water, Connected Places Catapult and CMCL for sharing their project learnings with us so openly today. I believe my colleague has just popped the poll link into the chat again about today's session. So please do take a moment to give us some feedback. We find it extremely valuable. As mentioned at the beginning, we'll be posting the recording of today's showcase on our platform along with the case study, and that should be available within the next week. Any questions that haven't been answered during today's event will be uploaded alongside these two. Thank you again to everyone for coming, and have a lovely rest of your day. Bye.
Thanks all.
Thank you all. Have a
Thank
good
you,
one.
everybody.
Thank you, everyone.